Assalamu alaikum. This is Muhammad Gyashuddin. Welcome to the GFC school. Guys, today I'll discuss escape velocity. Escape velocity root to gm upon r. Guys, we have to determine this and what do you mean by escape velocity? Could you tell me? Guys, escape velocity means a minimum velocity by which an object or projected from the surface of the earth and the object doesn't come back to the earth. That velocity is called projected velocity, the minimum velocity. The minimum velocity, the minimum velocity. Okay, by which an object is projected from the earth surface, from the earth surface, and it doesn't come back. It doesn't come back to the earth. Come back to the earth. That is called escape velocity. That means it's a minimum velocity, and for finding out this equation, we have to know the gravitational force. Guys, suppose the mass of the object is m and the mass of the earth is capital M. Okay, it's the mass of the object which we want to project from the surface of the earth, and this capital M is the mass of the earth. And actually, let me draw a picture. Suppose this is the surface of the earth. Okay, this is the surface of the earth, and it's a radius of the earth. Okay, and from the center, okay, from the center, at our distance, an object. Okay, and we wanna try to move this object from this to this point. Okay, this point and this dr distance. Guys, try to remember this picture, and if you can remember this picture, then you understand main thing of this description. Guys, here is radius is the distance from the center of the earth, at which point the object is. Okay, just we're thinking, and after a certain time we want to displace the object from this to this, that is their distance. So guys, here the mass of the earth is m, and small m is the mass of the object. Then we can say what we can say: gravitational force between small m and capital M gm small m upon r squared, because at r distance the object remains. Okay, yeah, this is the force between earth and the object. It's a attractive force. Okay, this force we got between earth and object. Now we try to displace this object r distance. Okay, this object we are displace from this point. Suppose this is a point and this is b point. Okay, we want to bring the object from a to b r distance. Then we can say, what can we say? We can say work. Okay, this is work. What means, we know definition of work, the multiplication of force and distance. Here, force is F and distance is dr, and this is work which we have done. Okay, guys, now we got F equal to G capital M small r upon r squared dr. Now we'll do limit integration. By limit integration, we could get the scalar velocity. Sorry, potential energy. Guys, W equal to G capital M small m upon r square dr. From the basic of work, from the basic of Newton's formula, gravitational formula, we got this equation. Now we'll draw the object from R to infinity. When we project the object from the surface of the earth, that means this object will cross from the distance R to the distance infinity. So we have to do integration. And how can we do that? Guys, W, integration W equal to limit integration R to infinity. Okay, G capital M small r squared dr. Here, G M small capital R squared 1 upon r squared dr. Okay, if you do integration, what do you know? R squared means minus 2 plus 1, minus 2 plus 1, and we will divide by minus 2 plus 1. This is the rule of integration. Guys, we have done the integration. Now we have to put the limit. Okay, here infinity upon r, and gm m. Okay, gm g capital M and small m, these are constant. Okay, these are constant. Now I have done the integration. Now I'll put the value of r and infinity. G capital M small m. Okay, r minus 1 integration infinity r. Okay, G m 1 upon r. Okay, minus 1 upon r infinity r. Now G m we'll put at first infinity minus. Actually, in formula we know minus sign, and this minus plus 1 upon r. That means G m this is 0, this is 0, and this. That means finally we got G m r. This is work done, and we have to apply this, and we have to know the kinetic energy of the projected object. What is the kinetic energy of the project? Guys, this is work done. By that work, we have projected the object from the surface of the earth. Okay. So for escaping from the attraction of the force of earth, we need kinetic energy. Okay. And that kinetic energy will be equal to this work. Okay. If kinetic energy by the escape velocity of that object is equal to this work, then we could say that projected object would not come back to the earth. So we have to know the amount of the equation of kinetic energy. What is the equation of kinetic energy? Guys, try to remember this figure. Okay, and kinetic energy, suppose the escape velocity VE. Okay, escape velocity VE, and kinetic energy equal to half m VE squared. Is that small m is the velocity of the projected object. Here, this kinetic energy and that work done is equal. W equal to kinetic energy equal. Okay, this concept we have to remain, otherwise we can't do this mathematics. Okay, W we got G capital M small r equal to half mv squared, half mve squared. Cancel. Okay, we have to find out ve. That means ve squared r 2g. Okay, here ve squared 2g capital M R. Okay, that is 2gm upon r root. This is our required formula. Here, if you know the mass of the earth and gravitational constant g and the radius of the earth r, then we could find out the escape velocity of that object. And from this equation, we can say whether the escape velocity depends on the mass of the projected object. This is my question. Please tell me, does the escape velocity depend on the mass of the projected object? Guys, this is our required formula. Finally, we have got. And for getting this escape velocity equation, v equal to root 2 gm, we have to have three basic concepts. One is integration, and one is work done, and Newton's gravitational formula rule, and finally we have to understand the work done equal to the kinetic energy of the projected object. From this relation, we found v equal to root 2 gm upon r. Thanks a lot. Assalamu alaikum.